Alright, let's get right into carbohydrates. Okay, so on a chemical level, carbohydrates are made of carbon, hydrogen, and oxygen. They're the main source of fuel for the nervous system, for working muscles, and they also enable fat metabolism according to the Iowa State University. So monosaccharides, disaccharides, and multisaccharides, they're the main source of fuel to the body, as in the sense that they provide energy to the body. And in addition to that, two monosaccharide monomers, they are linked together through a condensation reaction in order to form a glycosidic bond and create a disaccharide. Okay, so to add to this, all organic compounds, they have the similar formula of carbon and H2O. And then the X and the Y are the amounts of each of the elements or molecules. And these numbers as well, they define what the organic compound is. So you can identify the organic compound based on these two numbers right here.
Okay, so we're going to be talking about the glucoses. There are the two main types of glucose. There's alpha glucose and beta glucose. And glucose is the most important form of carbohydrate for us because it's found in our blood circulation and it's our main source of energy. But anyways, that's not important for now. So alpha glucose, you can determine it by there being an OH on the bottom in the first bond with the carbon first atom. Okay, and that's different from the beta glucose, but that'll be explained later. I'll talk about the focus points now in the molecule. There are different focus points. Usually in different molecules, you could find that there could be a C written here, but it means exactly the same thing. Where there's a focus point, there means that there is a carbon atom. Okay, and in molecules of glucose, you can find that there always has to be a alcohol. This part is really important. The alcohol is going to be found in all molecules of glucose. And you can usually find numbers next to the carbon, which will be labeled as the first carbon atom, the second, the third, the fourth, the fifth, and the sixth. Just is in the chemical formula of glucose, which is C6H12O6. The 6 carbon atoms, the 12 hydrogen atoms, and the 6 oxygen atoms. And now in beta glucose, you can see that there's the distinct difference with the OH rather than in the alpha glucose, where the OH is on the top rather than being on the bottom. And there is a different type of beta glucose as well. There's beta glucose galactose. And what that is that it's basically the OH will mirror what's on the fourth carbon atom will mirror the first carbon atom. Rather than the OH being here, it'll be up here. And that is a beta glucose galactose. Alright, so now we'll be talking about the glycosidic bonds that occur between the first and fourth carbon atoms of two different alpha glucose molecules. So the most important thing that we need to know is that a bond is created when an OH and a hydrogen from just one are removed. That's a molecule of H2O. So a molecule of water is removed. And that creates the glycosidic bond in a alpha between two alpha glucose molecules. Now, with beta glycosidic bonds, one important key factor is that it doesn't occur between two beta glucose. It occurs between one beta glucose galactose molecule and one beta glucose. So there has to be one beta galactose and reacts with a beta glucose. And once again, a molecule of water is removed. So once that molecule of water is removed, you get a bond between the two beta glucose molecules, the beta galactose and the beta glucose.
Now, let's talk about polysaccharides. As I mentioned before, polysaccharides are multiple monosaccharides monomers added together, linked together. Therefore, they're anabolic and they need ATP to be used. because they need energy. Now, polysaccharides are starch, glycogen, and cellulose. They are linked together by a glucose molecule. Therefore, they're called those glucose molecules being linked together are also glycosidic bonds. Now, there are three types of hydroxide that are used in polysaccharides. The most common is basically the D1 to 4 linkage, which is basically when the carbon, the first carbon of one molecule and the fourth carbon of the second molecule are linked together after the loss of one water molecule. Now, moving on to cellulose. Now, cellulose are linked together, are made and linked together by the condensation of a beta glucose molecule, and they're found in a straight chain. They're distinct because they form bundles of hydrogen bonds, and those are called cellulose microfibrils.
Okay, so now moving on to starch. Starch is linked by the condensation of alpha D glucose molecules, and they are only made in plants. They are hydrophilic and they are mainly used for energy storage. Now, and there are two types of starch. There is amylose and there's amylopectin. Okay, so now let's talk about amylose and amylopectin. In amylose, you can see there's an alpha D 1 to 4 linkage between the different glucose molecules, which is the linkage between the first carbon atom of one molecule and the fourth carbon atom of another molecule. And you can find them to be in a chain structure. In amylopectin, you can see it's similar to amylose with the same chain base. However, it'll also have an alpha D 1 to 6 linkage, which will be stacked on top of the chain. Now that is similar to glycogen in the sense that glycogen is basically amylopectin, but it is a further more stacked structure of amylopectin. It'll have more 1 to 6 linkage and 1 to 4 linkage, but it'll all be stacked on top of each other to create a bigger molecule, which is glycogen.